Hello guys, welcome to Satya. Now we are here with the fourth part of binomial theorem. First of all, let's rewind the part 3. At last of the part 3, we learned how to find the irrational and rational terms. X power 1 by a plus y power 1 by b whole power n. This is a binomial expression where the general term t of r plus 1 and the main condition is x and y are prime numbers. T of r plus 1 equals to NCR x power 1 by a whole power n minus r y power 1 by b whole power r. X power n minus r by a into y power r by b. So now look here, it is said to be rational terms only when n minus r divisible by a and r is also divisible by b, and irrational terms if n minus r is not divisible by a and r is not divisible by b. We will get a clarity by solving the problems. Before solving problems, we have to learn 3 more properties of divisibility and finding remainder. So now, x plus y whole power n. Its expansion is nc naught, or else let's take 1 plus x whole power n. So the example would be easier. 1 plus x whole power n is nc naught plus nc1x plus nc2x square plus so on ncn x power n. So now nc naught is n factorial by n minus 0 factorial into 0 factorial. So it is n factorial into n factorial, which is 1. 1 plus nc1x plus nc2x square plus so on ncn x power n. Here, if at all we bring 1 to left hand side, the remaining equation is divisible by x. So we can take common x here in all terms up till x power n. We can take x common and nc1 plus nc2x plus so on ncn x power n minus n. So by this we can say that 1 plus x whole power n minus 1 is divisible by x. Similarly, if we take 1 plus x whole power minus n minus of nc1x, so I am taking these two terms to LHS, and now in all these terms we can take x square common. X square into nc2 plus nc3x plus so on ncn x power n minus 2. And here we can say that 1 plus x whole power n minus 1 minus nc1 into x is divisible by x square. If we take this nc1 to RHS, then it will be remained as a remainder. Okay, this is the first property, and the second one is x power n minus y power n is divisible by x square minus y square if n is even. This is a condition. Next one is x power n minus y power n is divisible by x minus y if n is odd. And the next is x power n plus y power n is divisible by x plus y if n is both even or odd. Remember these 3 points. The next is third point, which is very important. If any number n containing k as its digits place, k is a random value. Let's take any example, 5, 2, 4, k. This is a number where k is in units place. Five to 4k, if its power is something as smaller. So the units place decide the value of the total power. See if at all the k value is 0. Let's take 10. 10 square is 100, right? 100 square, 1000. At last, again we are getting 0 at the ones place. The units place is 0. And if k is equals to 1, take 11 square. The unit place is 1, right? 11 square is 121. Again we are getting 1 in the units place. Same, the units place is 1. Same like that 5. 5 square is 25. 25 square is 125. See, we are getting the same 5 in the units place. So, is 5. If k is 6, 6 square is 36. 36 square is 256. See, again we are getting 6 at the units place. See here, these are the numbers which on powering the units place does not change. 0, 1, 5, 6. You can say only these 4. Yes, if we take 2 or else 3 or any other number, first of all I will erase it. Now let's take the units place as 2. You can check casually, 2 power 1 is equals to 2, 2 square is equals to 4, 2 cube is equals to 8, 2 power 4 is equals to 16. So the units place is changing on multiplied with 2. So again 2 power 5 we get 32. So after 4 times multiplication of 2, again we are getting the units place as 2. So by this we can get an expression for it. 2 power 4n plus 1 is equals to 2. 2 power 4n's units place is 2. 2 power 4n plus 2 units place is 2 power 4n plus 2 unit place is 4. 2 power 4n plus 3 units place is 8. 2 power 4n plus 4, which is nothing but 2 power 4n. We can write it as 2 power 4n, okay? Units place is 6. Okay? You can check it also. Now, let's take here the value as 1, okay? 1 or else. See, we will check it. 2 power 4n plus 3. Put the n value as 1. 4 plus 3. 2 power 3 plus 4. 7. 2 power 7 is 2 power 5 is 32. 2 power 6 is 2 power 6 is 64. And 2 power 7 is 128. See, the units place is 8. And here we have the value 8. In this way, we can obtain the units place if at all we have the k value as 2. or else in the units place we can check these properties. Similarly for 3 and 7, if k is equals to 3 power 4n plus 1 is 3 power 4n plus 2 is equals to 9, 3 power 4n plus 3 is equals to 7. This is equals to is representing the units place after its power. 3 power 4n is equals to 21. 4n is equals to 1. And next for 7. For k is equals to 7 power 4n plus 1 equals to 7 power 4n plus 2 is equals to 7 7 is 49. So 9, 7 power 4n plus 3 is equals to 49, 9 power 9 7 is 63. So the units place is 3 and 7 power 4n 1. Okay. And next, now we are done with 1, 2, 3, 4 is not done, right? 4 has a unique property. 4 power 2n plus 1 is equals to 4 and 4 power 2n is equals to 6. So you can check it. 4 power 1 is 4 and 4 power 2 is 4 for 16. 4 cube 16 for 64. So the units place is alternative 4 and 6. We get the alternative terms 4 and 6 as their units place. See a special condition of 4 and 2, 3, 7 are of same kind and 1, 5, 0, 6 are of same kind. Okay. Let's see some problems now. How they ask in exams the problems based on binomial theorem. If find the number of rational terms in the expansion of nine power 1 by 4 plus 8 power 1 by 6 whole power 1000. We get confused and we will leave the question by seeing the power. 1000 is a big term, right? But here no need of expanding. They asked to expand for the number of terms of expansion, but no need of expanding here. They just asked how many rational terms are there in this expansion. So now, first of all, simplify this. As I said, finding the irrational and rational terms, property at the first. X and Y should be the prime numbers. So 9 can be written as 3 square. 3 square into 1 by 4 plus 8. 8 means 2 cube into 1 by 6 whole power 1000. This is a simplified way. 2 ones, 2 twos, 3 ones, 3 twos. 3 power 1 by 2 plus 2 power 1 by 2 whole power 1000. So 3 and 2 are prime numbers, right? Now 1 by 2. 1000 by 2 is 500. So 500 terms are divided, or else 500 rational terms are there in this. There will be option 500. In a hurry we will take that, but it is wrong. 500 is wrong because 0 can also be the answer. Okay. In a clear manner, let's write the general term. T of r plus 1 is equals to 1000 CR x power n minus r. 1000 minus r y power r. This is a general term, right? For some time, forget the 500 as the answer. Now, T of r plus 1 is equals to 1000 CR 3 power 1000 minus r by 2. 2 power r by 2. Now, for being a rational number, 3 should contain a whole power or a whole number as its power, and 2 also should contain a whole number as its power. For being a whole number, 1000 minus 2, 1000 minus r should be divided by 2. So now, if r is a multiples of 2, then it can be divided by 2. So r should be 2, 4, 6, 8, so on up till 1000. Okay. There are 500 terms here. Same r by 2. R by 2. R can be 2, 4, 6, 8, like that up to 1000. We got 500. But these are the natural numbers. There is a number 0, which can be also the rational term. See, if you put the value of 0 as r, 1000 minus 0 by 2. So it is also divisible by 2. 1000 by 2 is 500. And r by 2, 0 by 2 is 0. Something power 0 is 1. So we get the rational number if you put the r value as 0. So there are 500 plus 1 term, which is another one is 0. Total 501 rational terms are there, and the remaining terms are irrational. How many terms are remaining? As there is 1000, the number of terms in a binomial theorem are n plus 1. If it is n, then the number of terms are n plus 1. Here n is 1000, so 1000 plus 1 is 1001. 1001 are total terms and 501 are rational terms. By subtracting from it, we get 500 r. 500 terms are irrational terms. Okay. And last problem for today. Find the integral terms of 5 power 1 by 2 plus 3 power 1 by 8 whole power 1024. The options are 129, 128, 64, 0. Now, find the integral terms. Integral terms are nothing but the rational terms. First of all, see here the powers are 1 by 2 and 1 by 8. See here 8 can be divided by 2. So, if the power 1024 is divided by 8, then it is also divided by 2. So, 1024 by 8. We get the value as 128. In a hurry, we put the answer 128, which is B, but it is wrong. As we discussed in the previous problem, 0 is also a integral term or a rational term. So, the number of integral terms are 128 plus 1, including the 0. 128 plus 1, which is 129 is our correct answer. Be careful while doing these problems. That's it for today. Please like, share and subscribe Satya channel. If there are any comments or suggestions, please drop them in the comment box. Thank you.